Hey everyone, and welcome. Today, we're going to dive into the two big ways we make sense of all the data out there: data mining and statistical analysis. You can kind of think of one as a detective, searching for hidden clues, and the other as a scientist who's busy testing a theory. So let's break down how they work and why it really matters.
Just think about it. We're living in this incredible era where we're creating more data than at any other point in human history. Every single click, every purchase, every social media post, it all adds to this massive digital universe that's basically doubling in size every couple of years. The challenge isn't getting the data anymore, it's figuring out what it all means.
And that right there is the million-dollar question for pretty much every company and organization today. Hidden inside all of that raw data are the patterns, the insights that can help us predict trends, make services better, and really drive new ideas. But how on earth do you find them?
Well, the answer really lies in two super powerful approaches: data mining and statistical analysis. Let's stick with our analogy from before. Think of them as the detective and the scientist of the data world. Each one uses a totally different method to turn all that chaos into some real clarity.
Okay, so first up, let's talk about data mining. This is our digital detective. The key here is you're not starting with a specific question or a theory. Nope, you're just sifting through a gigantic pile of data, using algorithms to automatically find connections you didn't even know you were looking for. You've probably heard the classic example. A supermarket uses an algorithm and discovers that people who buy diapers on Thursdays also tend to buy beer. They weren't looking for that pattern, but now they can act on it.
Now, data mining isn't some magic wand you just wave. It's actually part of a bigger process called knowledge discovery in data, or KDD for short. You've got to collect the data, clean it up, get it into the right format, and then you apply the mining algorithms. But honestly, the most important final step, that's all human. It's about interpreting what the machine found and turning those patterns into real, actual insights.
All right, so our second tool is statistical analysis. If data mining is the free-roaming detective, this is our scientist in a lab coat. With this one, you almost always start with a hypothesis, an idea you want to test. You use proven, established mathematical rules to analyze the data, see if your idea holds up, and then draw objective, data-driven conclusions.
So the goals of statistics kind of follow this really logical path, right? First, you summarize the data just to get a handle on it. Then, you use it to test a very specific idea. Based on how that test goes, you can start making predictions, which ultimately gives people the solid evidence they need to make smart, informed decisions.
But here's the thing. Statistical analysis isn't just one thing. It's more like a whole toolkit. And depending on the question you're trying to answer, you're going to reach for a different tool. So let's take a quick look at the main types of analysis you'll find in this kit. First up, we've got the most fundamental tool: descriptive analysis. This is all about looking backwards. It takes a really complex data set and just boils it down into something you can actually understand, like a bar chart or a simple average. It tells you exactly what happened, but it doesn't explain why it happened or what's coming next. Next, we have inferential analysis. Now this one is incredibly powerful. You can take a pretty small, manageable sample, like say a survey of 1,000 voters, and use it to make a reasonably confident guess or inference about how an entire country might vote. It's amazing stuff. And then there's predictive analysis. This is where we start to gaze into the crystal ball. It uses all that past data plus some fancy models to forecast what's likely to happen in the future. This is the engine behind everything from your local weather report to big Wall Street sales forecasts. Okay, so knowing what might happen is definitely useful, but the logical next question is, what should we actually do about it? And that is exactly where prescriptive analysis comes in. This is the most action-oriented tool in the whole kit. It doesn't just predict what will happen, it actually recommends what you should do to get a better outcome. Think of it like a GPS app that doesn't just predict traffic, but actively suggests a faster route to take.
Now, a super important first step in almost any project is what's called exploratory data analysis, or EDA. This is where the analyst kind of puts on their own detective hat, just poking around in the data, making charts and graphs, looking for anything interesting or weird that might need a closer look.
Finding a pattern is one thing, but understanding what caused it, that's a whole different ballgame. Seeing that your sales went after you launched a new ad campaign doesn't automatically mean the campaign caused the increase. Answering the why question, well, that's the next level.
And answering that why is the whole point of causal analysis. Honestly, this is kind of the holy grail of data analysis. It tries to separate simple correlation from true cause and effect. It helps you figure out if your ad campaign actually caused more sales or if it was just a coincidence. It's incredibly hard to do, but man, is it valuable.
So we have data mining and its automated discovery, and we have the structured hypothesis testing world of statistical analysis. So how do these two actually relate to each other? Are they in competition or do they work together?
While their main focus is just different, data mining is all about that automated discovery in huge sets of data. Statistical analysis, on the other hand, is more about structured interpretation and testing ideas you already have. You could say one is about finding the what, while the other is often about validating it and figuring out the why.
So the single most important takeaway is this. They are not rivals at all. They're powerful partners. For sure. You might use data mining to find some totally unexpected group of customers, and then you'd use statistical analysis to test a theory about that group's behavior to make sure the finding is real and not just some random fluke. They really do work best together.
Now, all these concepts might sound a bit academic, but trust me, both data mining and statistical analysis are shaping your world every single day in ways you might not even realize. Let's look at just a few examples.
I mean, think about the last time you got a fraud alert from your bank. A data mining system is constantly looking at millions of transactions to learn what your normal spending looks like. So when a charge pops up that breaks that pattern, like a big purchase in another country, it gets flagged. That exact same logic is what powers movie recommendations, those targeted ads you see everywhere, and even things like predicting health risks.
So let's step back for a second. What's the big picture here? What's the ultimate goal of all this data crunching and analysis?
It really all boils down to this. Whether you're using data mining or statistics, the end goal is always the same: to turn messy, chaotic, raw data into a clear, actionable insight that helps someone make a better decision.
And that leaves us with a really critical question for the future. I mean, these tools are getting more powerful every single day, influencing what we buy, the news we see, even our health. So as we get better and better at finding that signal in the noise, the real challenge is going to be making sure that signal leads to decisions that aren't just smarter, but are also fairer for everyone.